Okay, welcome back. Let's talk a little bit now. We're going to do examples of both a weighted average cost of capital analysis. We're going to walk through the one that's in the valuation template. We're also going to do a DCF analysis. I'm going to do a quick and dirty DCF for Kraft. So I am on the WACC tab of the valuation template, and you should have these exact numbers on your screen as well. So what I'm going to do, again, I'm going to walk through, I'm going to show how the weighted average cost of capital is calculated for all 5 of our comps, and then I'm going to show how we calculate the weighted average cost of capital using some of these data selectively for our company A. Okay, so for each of our comps in our WACC template, and this is a complete analysis, so we're really just going to walk through and show all the components and explain it to you. We're capturing several different important characteristics. We're capturing, first of all, capital structure. Okay, how much debt, how much equity do each of our comps have? And you'll notice if you put your cursor, if you highlight any of these cells, you'll notice that we're not hard coding any data here. Right, these are all black. All this text is black. Rather, we're actually linking to our comp spread tab. We've already captured these. We've spread each of our 5 comps. We have their debt, we have their preferred, we have their market value of equity. We've calculated their total capitalization or their total enterprise value. All right, so rather than redoing it here, we're linking to data that we've already captured. We're also going to capture debt to equity ratios. Again, when we unlever and relever beta, these are going to be important. This is the indication of each company to the extent to which it uses leverage. And there's some variability in here. Kraft, obviously, far more heavily levered than Kellogg. We capture debt to total capitalization. Okay, Kellogg being the lowest at 25% debt. They've got 75% equity. Kraft is the highest, 34% debt, 66% equity. These items here add up to 100. All right, as they should. Any questions on that? We'll show you how these come into play a little bit later. As we go down this slide, now we're capturing a bunch of different items that should look familiar. These are items that are going to be specific to our capital asset pricing model. We obviously need a levered beta on each company. You'll notice that these are hard-coded. The reason they're hard-coded is we haven't come across this yet. I can't link to anything. All I've done is look up beta for each company. And I've used a 5-year beta. I show the source of my data down here below. I think I got my betas from a research service called Zacks Investment Research. I was able to look up those betas. So again, we look up the levered beta, and then to remove the effective leverage, we unlever beta for each of the comparable companies. So Kraft's levered beta is 0.63. When we unlever it, we get to an asset beta or an unlevered beta of 0.47. We do the same for each of our companies. And then we come up with a median unlevered beta of 0.46, a mean unlevered beta of 0.42. And that formula that we're using for our unlevered beta should look familiar. We're taking our levered beta, divide by 1 plus 1 minus the tax rate times the debt to equity ratio. Right? Equity risk premium, this term that we have out here, that's the term in our CAPM that we multiply by beta. Again, this is something we've just looked up. And in this case, you'll see that we're referencing another cell C57, which is down here, which is also linked to cell AE105. Let's go over and show where that is so you can see how we've set this up. As you scroll down and to the right now I'm in cell, Z99. So kind of over in that direction. We've captured the long-term, intermediate term, short-term equity risk premium. I got these from Professor Demoteran's site, but he uses the Ibbotson data and just calculates those. And so we're using the long-term equity risk premium, 6.42%, which again feeds into our CAPM model up here. And now that we've got beta, now that we've got equity risk premium, and now that we've got a risk-free rate, which is also down here, the 20-year Treasury bond, cell C56. As of our valuation date, I looked it up on the Fed website, the 20-year Treasury was 2.89%. So our cost of equity, if we look in column O for Kraft, we're looking in cell O28. We're simply taking the risk-free rate plus their levered beta times the market risk premium. Pretty straightforward. As I mentioned before, we're looking up all those inputs and then doing the math. Now, cost of debt. In the case of the cost of debt, we actually do a little bit of analysis that's based on these companies' debt footnotes in their financial statements. And if you look in cell Q28 for Kraft Foods, their cost of debt 6%. We're linking to cell AX141. So if we scroll way out to the right and down, going down to that AX41 cell, right, you see we've calculated a cost of debt of 6%. The way we've done that, and we do this for every company the same way, is we're analyzing each individual piece of debt that they have from their debt footnote. And these items that I've highlighted here match their debt footnote exactly. So in the case of Kraft, they've got some long-term notes that have due dates through 2039. They've got some euro notes due through 2015. They've got a 7% bond due in 2011. They've got some other foreign currency obligations. They've got some capital leases and other debt. Where the data are available, we're capturing the following. Capture what is the amount outstanding and what is the interest rate. Based on these amounts outstanding, we calculate what is the percent of their total debt, what is the weighting of their total debt, does each line item represent. We multiply that by that individual debt's interest rate to get a weighted average. Right? And then when we add those up, we've calculated a weighted average cost of debt of 6%. Pretty straightforward. The only caveat here that I'll mention, and I've kind of put some comments in these cells, some of these items, even though they were listed in the debt footnote as having an amount associated with them, we didn't capture that amount because they didn't include interest rate information. All right, so for these other currency obligations, there's actually a pretty small amount, but they didn't tell us what the interest rate associated with those was. Same for the capital leases, so we've left them out. We list them, and we show these comments to show we didn't overlook it, but because we didn't have enough data to calculate a weighted average interest rate, we've basically excluded them from the analysis. And we do the same thing for every one of our comps. Okay, so if we look at ConAgra, we've basically replicated their debt footnote. For Heinz, same thing. General Mills and Kellogg. And so that cost of debt that we're capturing in our model up above in this column Q, that's where that's coming from. All right, now that we've got cost of equity, we've got cost of debt. Cost of preferred in this case is 0 for each company. They don't have any preferred. If they did, it would be noted what the preferred rate of return is on that preferred stock. We'd capture it here. But now that we have cost of debt, cost of equity, we've got the relative weightings in the capital structure up here. We've also got the tax rate. We can multiply them out, calculate a weighted average cost of capital for each company. And that's exactly what we're doing in this formula here. Same formula we showed in the slides. We're just putting it to work here to calculate a WACC for each company. And when we look at all the data, we have weighted average cost of capital ranging from 4% to 6.7, median of 5.9, mean of 5.6. So it's pretty safe to say for these companies, weighted average cost of capital around 6%. So that's interesting, that's well and good. We know what the WACC is for each company, but the goal is to figure out what is the WACC for company A. We're trying to value company A. Your homework is going to be to do a DCF for company A. So what should its discount rate be? And this is where we apply the data we've captured above to company A specifically. Okay. Company-specific risk premium, I'll come back in a moment. I touched on it during the lecture. I'll show you in a moment how that's taken into account. because that's something we can use. All right, and the key information we're going to pull from our comps is going to be twofold. Number one, what is their unlevered beta? We talked about that before. And in this case, we're going to use the median unlevered beta of our comps. We're going to source that from the data we've captured above. Cell K34 is the link. It tells us that the median unlevered beta is 0.46. And what we do from this point is now we need to relever that beta, as I talked about in the slides, to capture the leverage specific to company A. Now again, if you've got a client, you've got access to the CFO, they can tell you our target capital structure is 40% debt, 60% equity. Great. You can probably go ahead and use that. All right. But in this case, company A is made up. In other cases, you may not have that information from the company itself. We're going to actually rely on the median values of our comps to tell us what their quote-unquote optimal or target capital structure might be. All right, so if we look over here, we capture the mean, or the median debt to enterprise, equity enterprise values, and we'll use the median debt to equity ratio, basically to calculate, to relever our beta. And that's all this formula is here. Same formula as I showed in the slides, formula for levered beta. So we relever that, we get our levered beta of 0.61. Now we've got everything we need to capture, to calculate our capital asset, use our CAPM, calculate our cost of equity. And then in this case, we're going to assume, for company A, we're just assuming a cost of debt of 6%. Right? Maybe it's higher, whatever it actually is. Ideally, we can get that from the company or from their financials, show us what their actual cost of debt is. Since company A is a made-up company, I'm just picking 6%. Reality, they're a lot smaller. They're probably not going to get 6% debt when Kraft and the other companies are getting 6% debt. They'll probably pay a higher coupon, but is what it is. All right, so we assume a 6% cost of debt. We calculate a cost of equity using our capital asset pricing model, which ends up being 6.8%. And if we calculate a WACC based on that, it gives us 5.9%. Again, company A, made-up company, private company, a lot smaller than our comps, probably not going to have a cost of debt identical to the comps, probably not going to have a cost of equity identical to the comps. And here's where a company-specific risk premium can come in handy, or can come into play. If we look at our cost of equity formula, we'll see that we're taking our risk-free rate plus beta times the equity risk premium, but then on the end we're actually adding on a term for the company-specific risk premium. This is where the model can be a little more subjective, a little more flexible. This is also where an analyst or an associate can quote-unquote manage the valuation to get the numbers to come out the way they need to. All right. That's actually, it's rare in investment banking that you go into a valuation exercise completely blind. That is, I have no idea where this company is going to be valued when I finish this. Typically what happens, especially if you're getting invited to go pitch to try and win, say, a piece of M&A business, typically the company is going to give some indication of where they expect valuation to come out. It's the investment banking analyst, associate's job to find a way to support those numbers. And a company-specific risk premium is a way that analyst or an associate can bring down those numbers if DCF is giving a result that's way too high. So if I go back to my company-specific risk premium and I say, all right, my valuation's coming out too high, let's add a 3% premium. That's basically a straight add-on to our cost of equity. So it boosts our cost of equity. Instead of 6.8%, now it's almost 10. It's 9.8%. If we run that through and weight it, it boosts our cost of capital from 5.9 to 7.9, or almost 8%. All right. So that company-specific risk premium can be used, again, to account for a number of different factors. Maybe the company's very small. Maybe it's got a key person. Maybe they've got some crazy projection assumptions. Right? But for whatever reason, it should be something that you can support, you can justify, it's also something that can be useful in managing valuation numbers down to an acceptable range. We'll talk about that a little more when we get into pitching in Class 8, talking about how we want to manage our numbers and come in terms of the pitch. You don't want to come in way too high valuation when you're pitching for business, because if all the other investment banks are at a certain number and you're way above that or way below that, that can be problematic in terms of winning business. So that's one reason why we might use that. All right, but we'll talk a little more about that later on. Right. If there are no more questions on WACC, what I want to do now is I actually want to build a DCF for Kraft Foods. And if you go to the DCF-Kraft example tab, if you go actually in your valuation folder and you open up that shell model, and go to the DCF Kraft example, you can follow along with me. Your numbers are filled in. But similar to the spreading exercise I did in class last week when I spread Heinz, in my model I've taken the numbers out and I'm going to recreate that so you can see the methodology that goes into building not just a DCF but also a stripped down set of projections. All right, so if you just want to follow the exercise with the answers filled in, open up your shell model, and I'm going to basically populate my model, and at the end of the day it should equal what you've got on your screen. Okay, so here's the situation. I'm trying to do a DCF for Kraft just for fun, and all I've got at this point, I've got the first 2 years of forecasts, which I got from the analyst reports. Remember that. We looked at those Credit Suisse reports, pulled the projections. All right, as you can see here, in both of these columns, I'm linking to my comp spread tab. If you were to follow that link all the way back, it's just linked to where we spread the analyst forecasts. But like I said earlier, DCF is usually a 5-year period. So before I can do a DCF, I need to forecast 3 more years of results. All right, so that's the first thing I need to do. Remember back to those 4 steps of a DCF. I need to do step 1. I need to forecast free cash flows. The way I'm going to do that is using some assumptions. I'm going to make some assumptions as to how quickly I think Kraft's revenues are going to grow, what type of profitability or EBIT margins they're going to have, how much depreciation and amortization they should have, what type of capital spending they're going to be doing, and how much they're going to need to invest in their working capital to support that growth. And the place that I'm going to capture those assumptions, if we scroll over to the right into cells Q, or into columns Q, R, S, and T, we can scroll down and we can see a list of quote-unquote key assumptions. This exercise I'm doing here is it's basically identical to what you're going to do in your homework. All right, so I'm going to do it here. You're going to get a chance to replicate it on your DCF homework tab tonight, or whenever you get around to doing homework. But here are the assumptions that I'm going to use in building these stripped down forecasts. And this will be helpful also tomorrow when we build a full set of projections. The first thing here that we've got listed is something called a stub period. We're going to come back to that in a few minutes.